This is lesson 2.1, the power rule. Hopefully by now you've had a chance to look at the polynomial preview/review that I posted for lesson 2.0. You should take some time to make sure you're comfortable with all of the material from the practice questions. It should all be review from for you functions. Unit 2 is going to build on what you've learned about using limits to find the equation of a line that is tangent to any point on a parent function, and using limits to determine that. And we're going to do this by looking at polynomial functions first and establishing some more rules to live by that will make it easier to find the equation of the derivative going forward. And hint, hint, you're not going to have to use that big definition of derivative equation very much longer. So let's start by looking at this graph with two parent functions on it. The red line, f of x, has the same y value for every value of x, and that is y equals 3. So y equals 3. So for every value of x, it doesn't matter where I am along the x-axis, y is going to equal 3. Therefore, the equation of the function is f of x equals 3. This line has a flat slope, or it's a flat line. Therefore, the slope is equal to 0. So our derivative is going to be f prime of x equals 0. And we would draw our tangent line right along the x-axis because our slope is 0 for every point along that function. The blue line, g of x, is another function. We can see that it's linear, so to determine the equation, we need the slope and the y-intercept. Reading the slope right off of the graph, we can see that it's going down 2 and over 1 for every step in the graph. We also can see that the line passes through the origin, so the y-intercept is 0. Therefore, the equation of this function is going to be g of x is equal to negative 2x, and that's it. There's no b value. Since the slope of this line everywhere is negative 2, if we were to draw the tangent on here, we would be drawing a flat line where y is equal to negative 2. And that's because the derivative of this, so g prime of x, is actually equal to negative 2. That's just the slope of that function. I'm hoping you might be seeing something happening here, maybe a little bit of a pattern. So let's look at our first new rule. Our first rule for this lesson is the constant rule, and we're going to be able to use this rule to find the derivative without using limits or small center intervals. And this rule simply states that if f of x is equal to c, and c is just some constant value, then the derivative f prime of x will equal 0. I want you to add this to your rules to live by page that you should have started a couple of lessons ago. So from the first graph we looked at, if we have f of x is equal to 3, then the slope of that line is equal to 0. We know it's a flat line, so the derivative then is going to be f prime of x is equal to 0. And this holds true for any constant value. So if f of x is equal to 1, the slope of a tangent at any point along that line is going to be equal to 0. So f prime of x is equal to 0. If f of x is equal to 1,754, the slope of that line, a tangent line drawn anywhere along there, is also going to be 0 because it's a flat line. So f prime of x will equal 0. But what if the slope isn't 0? Let's look at some scenarios on the next slide. So, what would the derivative of y equals x be? Well, let's graph it. So, we know that y is equal to x. And what does that really mean? Well, that tells me that f of x is equal to x if we're going to use function notation. And that really just means that for every value of x, y just equals x. So, if I were to set up a table of values, when x equals negative 1, y equals negative 1. When x equals negative 2, y equals negative 2. When x equals 0, y equals 0, x equals 1, y equals 1, and so on and so on. If I were to graph this, I can see that it would be quite linear with a slope equal to 1 over 1, or a slope that is simply equal to 1. So what is the derivative of y equals x? Well, using Leibniz notation, dy over dx is equal to 1. The equation of the derivative is 1. What's the derivative of y equals 2x? Well, same thing. We could do a table of values, our x and our y. If x is equal to negative 1, then y is going to be equal to 2 times negative 1, or negative 2. When x is equal to 0, y is going to be equal to 2 times 0, or 0. When x is equal to 1, y is equal to 2 times 1, or 2. And if x is equal to 2, then y is equal to 4. We can graph this again, 1 and 2. We see it's a little bit steeper. And our slope for this one, our slope is equal to negative 2. So what's the derivative of y equals 2x? Well, it's dy over dx equals negative 2. So let's talk in some more general terms. I'm hoping by now you're seeing a pattern. So what is the derivative of y equals mx? Well, the derivative of y equals mx, or dy over dx, is just equal to m. So if f of x equals mx, the derivative will be the constant in front of x. Whatever the slope is in our formula will be the derivative, the equation of the derivative. I want you to take a few minutes and pause the video and use the definition of the derivative equation to determine the derivative for each of the following functions. As a reminder, the definition of derivative equation is as follows. F prime of x is going to be equal to the limit as h approaches 0 of f x plus h minus f of x all over h. So pause the video and then come back. So using the equation, you should have found that the derivative of y equals x squared is y prime equals 2x. The derivative of y equals x cubed is equal to y prime is equal to 3x squared. And the derivative of y equals x to the power of 4 would be y prime equals 4x to the power of 3. What's the pattern? Well, as the power moves down in front of the variable, and the exponent then is decreased by 1. So the power moves down in front of the variable. The power moves down in front of the variable, and the exponent decreases by 1. And the exponent decreases by 1. So this is the power rule, and the power rule says if f of x equals x to the power of n, then f prime of x will just be n times x raised to the power of n minus 1. Or in Leibniz notation, d of x to the power of n over dx is equal to nx raised to the power of n minus 1. So let's use the rule to determine the derivative of each of the following. So if we have y equals x to the power of 10, we are going to move the power down in front. So y prime is going to be equal to 10x, and then we're going to take 10 minus 1 as our new power to the power of 9. Y equals x to the power of negative 2, then y prime will be equal to, we're going to move the power down, so negative 2x. Now this is the one we have to think about. negative 2 minus 1, that's our n minus 1 value for our new power, will be negative 3. So the derivative of y equals x raised to the negative 2 is y prime equals negative 2x to the power of negative 3. This power rule is very handy to help find the equation of the derivative. It's much easier than using the definition of the derivative every single time. So, how does a constant multiple affect the derivative? I want you to take a few minutes again and pause this video to use the definition of derivative to determine the derivative of each of the following functions. And I promise I'm not going to keep asking you to do this, but I just want you to see where these are coming from. So pause it, try it, and then come back to the video and see if you were right. Okay, so hopefully you've done what I asked and you've done the hard work, and now we're going to take a look at it. So if y equals 2 times x to the power of 2, the derivative of this will be 4x. So dy over dx. So dy over dx is equal to 4x. My y equals 3x squared. The derivative of that, dy over dx, is going to be equal to 6x. And my derivative of y equals 4x squared, you should have found dy over dx is equal to 8x. This is our second, maybe third rule now, I think, at this point of this lesson, and this is the constant multiple rule. It basically just says that if g of x is equal to cf of x, and c is just some multiple of f of x, then g prime of x will be equal to c times the derivative of f of x, or f prime of x. The constant multiple, the number in front of the variable, is multiplied by the exponent, and we subtract 1 from the exponent. So it's kind of a hybrid between a constant rule. We have a constant in front, not really the constant rule I just told you, but we have a constant in front, and we're going to multiply that by whatever the derivative is when we use the power rule. So let's look at another example. So determine the derivative of f of x equals 8x cubed. I want you to pause the video and give it a try because I think you've got it figured out by now. Okay, here we are back. So what are we going to do? Well, we want to know the derivative. So I know that I'm going to take 3 times 8 because I'm going to bring that power down and multiply it by the constant. So 8 times 3 gives me a value of 24. So I'm going to have 24x. So my f prime of x is going to be equal to 24x. Now I need to figure out what's happening with my exponent. That's my n minus 1. So that would be 3 minus 1, which equals 2. So the derivative of f of x equals 8x cubed is f prime of x equals 24x squared. Now let's take a look at a question that asks us to find the equation of the tangent, that's just the equation of the derivative, of y equals 3x squared at the point where x equals 4. So there are 3 steps to this question. The first step is going to be to find the y value of the original point equation when x equals 4. And we're going to do that by substituting x equals 4 into that equation. So we're looking at this equation here, y equals 3x squared. So step 1, we're going to sub in. So y equals 3 times 4 squared, that equals 48. And that's going to give us our point. So we know that we have the point when x equals 4, y is equal to 48. The second thing that we need to do is we need to find the derivative of y equals 3x squared. So if y equals 3x squared, we're going to use the power rule to find this derivative. So we're going to bring the power down and multiply it. So the derivative, or y prime, is going to be equal to 3 times 2, which is 6, x, and now 2 minus 1 is just to the power of 1. And we don't need to write that. So now we're going to use this derivative, this y equals 6x, to find the slope when x equals 4. So we want to know the slope of this line when x equals 4, and we're going to do that just by substituting in. So my slope is equal to 6x, which is equal to 6 times 4, which is equal to 24. So the slope is 24. Now, the last step here is to put it all together. We're going to use the slope equation. Y minus y1 equals the slope times x minus x1 to put this into an equation form. And so we will have y minus our original y value of 48 equals our slope of 24 times x minus our original x value of 4. And it is okay to leave it in that form. The second part of this question asks us to determine the equation of the normal line. That means it's perpendicular. So that means that if I have some curve and I have a tangent line to that curve, my normal line is that perpendicular line. This will be my normal. And what this is asking us to find is the equation of that normal line, again, when x equals 4. So we know that the perpendicular slope, so perpendicular slope, just to remind you, is the negative inverse or negative reciprocal, is the negative inverse of the original slope. So my perpendicular slope in this case, if my original slope was 24, my negative inverse will be negative 1 over 24 for my slope. So then we're just going to go back and use this slope equation and plug in what we know. So y minus 48, that was my original y1 value, equals my new slope. This is my new slope, negative 1 over 24. X minus my x value of 2. And again, it is okay to leave it in this form. So what if our polynomial is a little more complex than just a 2x squared or a constant value? We need a way to determine the derivative of a polynomial that involves addition and subtraction. And so here are a couple of examples. So if I have my original function is y equals 2x plus 3, I'm going to tell you that the derivative is y prime equals 2. Now, if I have a different equation, let's say I have y equals x squared minus 4x, I'm going to tell you that this derivative is y prime is equal to 2x minus 4. Do you see how we got there? When we have multiple terms in a function that are added or subtracted, the derivative will be the derivative of each term added or subtracted together. And this is what we call the sum rule. So here's another rule. I've lost count of how many rules I've given you today. So here's another rule to add to your rules to live by. And the sum rule just basically states that the derivative f plus g, or f plus g prime, is going to be equal to f prime plus g prime, or the derivative of f plus the derivative of g. We can reverse this and say that it also could be f minus g prime is equal to f prime minus g prime. So you can have the sum or the subtraction rule. So let's look at another example. So state the derivative of y equals 2x to the power of 4 minus 4x. We're going to take the derivative of each term. So let's say this is f and this is g. So my derivative of f of x is going to be using the power rule. 2 times 4 is 8x, and 4 minus 1 is 3. My derivative of the second one, or g prime, is going to be, if I have 4x, that's just going to be 4. So now I'm going to put it all back together. So y prime is going to equal f prime minus g prime. So y prime is going to be equal to x to the 8x cubed minus 4. I'm hoping that you're seeing that as we're adding some of these rules, this is getting a little bit easier to do. And we're just going to build on these rules as we go. Okay, so let's look at this example. So at what points on the curve that's represented by y equals x cubed plus 5x squared is the tangent line parallel to the line 3x plus y equals 0? So let's decipher what this is really asking us. This is really asking us, when is the tangent, when will this tangent, this equation right here, have the same slope as this random line 3x plus y equals 0? Again, this is a multi-step question. You can do this in a slightly different order than I'm going to do it, but this is how I would tackle this question. So if I have to find the derivative. So that's going to be the first thing I'm going to do. I'm going to find the derivative of y equals x cubed plus 5x squared, and I'm going to use this sum rule. I'm going to use the power rule and the sum rule. So I'm going to find the derivative of my f, and I'm going to find this derivative of my g, and then I'm going to add them together. So my derivative of f prime of x is going to be 3x squared. That's using that power rule. My derivative of 5x squared, or my g, will be 2 times 5, which is 10x, and 2 minus 1 is just 1. So it's 10x raised to the power of 1. So now my second step for this, now I've got to put it all together. I forgot about that. So dy over dx is going to be equal to the sum of these two together, 3x squared plus 10x. Okay, so now that we've got that, now we need to know, well, what slope are we aiming for? And to figure out what slope we're aiming for, we have to find out what the slope of this line is. So if I have 3x plus y equals 0, I need to rearrange this into slope-intercept form. So y is going to be equal to negative 3x. Therefore, the slope of this line is going to be negative 3. So remember now that the slope of the tangent, so this equation that we just found right here, that is equal to the slope. So if I want to know when is this slope going to be negative 3, I'm going to make this equal to negative 3, and this is step 3. So I am going to set my derivative equal to negative 3. So negative 3 now equals 3x squared plus 10x. I'm going to rearrange it to get it to equal 0. So 0 equals 3x squared plus 10x plus 3. Now I need to factor to find my x values. So I'm going to pull, what am I going to pull out of here? I'm just going to factor it. So 3x plus 1, and then x plus 3. So there's my factors. And then I'm going to set 3x plus 1 is equal to 0. So x will be equal to negative 1/3. So that means I'm going to have, the slope is going to be equal when x is equal to negative 1/3. And then my other one that I have is when x plus 3 equals 0, or when x equals negative 3. So these are my 2 points on this original curve where the slope of the tangent will be equal to negative 3. So if we sub these values into the original y equals x cubed plus 5x squared, we can get the actual point. And I'm just going to make this bigger, and I'm going to do this just over here. So what is our y value when x equals negative 1/3? So negative 1/3 cubed plus 5 times negative 1/3 squared. And I'm just getting that from this equation here. That's all I'm doing, is I'm just using that equation there. Okay, so y will equal 14 over 27. I haven't said when the dust settles, so I'm going to say it now. So when the dust settles, my first point will be where that slope is equal to negative 3, will be when x is negative 1/3 and y is 14 over 27. I'm going to do the same thing with my other x value that I just found. So my y value when x is equal to negative 3 will be equal to negative 3 cubed plus 5 times negative 3 squared. So that y value, that will give me a y value of 18. So that tells me the second point on that graph will be when x is negative 3 and y is 18. Okay, so the last thing that I want us to look at today is some non-polynomial examples. So let's look at this first one. If I have y equals 1 over x cubed, we can rewrite this. So we can rewrite, anytime we have 1 over x raised to a power, we can rewrite that as the negative power. So 1 over x cubed is going to be equal to x raised to the power of negative 3. We know what to do with this. This is just the power rule. So I'm going to bring that power down. Negative 3x, I'm going to subtract 1 from the power to give me negative 4. So the derivative of y equals 1 over x cubed will be y prime equals negative 3x raised to the negative 4. Now, what about if we have a square root? Well, again, we can rewrite this. Remember that the square root is really just x raised to the power of 1/2. Again, this is just the power rule. We're going to bring this down and put it in front, or multiply it if there was a number there. So 1/2 x, and then we're going to subtract 1 from our power. So 1/2 minus 1 gives me negative 1/2. So my derivative of y equals the square root of x is y prime equals 1/2 x to the power of negative 1/2. I know that's a lot of new rules, but we're going to be seeing these over and over again throughout this unit and every unit that we're going to do from now on. So don't panic, just write them all down. Put them all on one separate page that you can refer back to as you go through and do the homework. Speaking of, here is the homework for today. So, page 83, I want you to do questions 1 to 6, 13 to 17, and question 21. I know it's a lot, but I think it's worth practicing because these are new things to you, and there is an exit ticket posted for this lesson.